Hey, hello, my name is Carl and I'm the marketing guy, but I actually have no idea how to use electronics. But today, Chris is going to tell me how to use it. So let's get started. Hi, my name is Carl
My name's Chris.
and Chris is going to teach me how to use TinyLab to have a look at this LED light.
Yep, experiment 1 is blinking an LED. So first things first, we've got to connect up the ground wire, of course.
Yep.
And then we're going to connect the top of this to the oscilloscope. And at the same node, we're going to have the signal generator. So it's worth noting, Carl,
Yes.
on this breadboard, all of those points there in one row, they're actually all physically connected. I'll disable fast mode for this experiment.
So this is the interface of TinyLab.
Mm-hmm.
Yes.
So this is where all of the equipment is basically, well, it's not stored, but this is how you interface with all of the things. So hopefully Carl will know what a signal generator and a scope is. We'll just quickly start by sending a waveform down. So that waveform generator there has generated a waveform and is sending voltage to this in a varying pattern. So it rises up for 0.01 of a second and then
Yep.
goes down again and then up again and down again. So you can
Yep.
see it, probably can't see it on camera, but it's flickering at 50 hertz here.
Yeah, I can definitely see that.
Yeah.
And I assume those flat region on top of them are clipping
Yes.
somehow.
Yes, it's getting clips because the power supply voltage feeds back into the into the op amp that drives the signal generator. So Carl, you don't need to know this. All you need to know is 7 is the magic number.
Okay, 7 is a magic number.
There we go. So if you want to make it actually visible, these flickers, so we'll change the frequency here. So now it's only varying at 1 time per second rather
Yep.
than 50 times per second, and you can see it slowly light up,
Yep,
slowly light down.
pretty obvious. That makes a lot of sense to me.
Mm-hmm. And with the oscilloscope you can zoom out and sort of see how it varies on a second by second
So it's
basis.
going to change the numbers on the axes,
Mm-hmm.
I suppose.
So yeah, you can see that there it represents, going up for half a second and then down for half a second.
Yep.
So we can look at other waveforms too on our oscilloscope here.
Oh,
So yeah, it slowly ramps up and then shoots off. So I guess that's what your waveform is.
so that pretty much determines how the light is going to be shown on the LED, I guess.
Yep.
Okay.
And you can also use it for other things like communications and stuff too. So all that means is that's how much voltage is on the LED,
Yeah.
and the more voltage there is, the more light there is.
Okay.
Yep.
Yeah, that makes sense to me.
So that's about it.
So, hello, Chris. Would you be able to tell us what our second experiment is going to be?
Our second experiment will be a 555 timer experiment. So we'll be building an astable multi-vibrator with TinyLab, powered and measured. Thank you.
All right, let's get started. Are you going to do it or am I going to do it?
We'll let Carl build this one.
All right, it's going to take a while. As I said before, I constructed a 555 timer with an LED light, and now I'm going to connect this circuit to our TinyLab. So first of all, I'm going to connect it first. So this is what Chris has taught me, and I don't want to. It's in the wrong spot. Is that the correct one?
Yeah, it's top of the LED.
Oh, here we go. Oh,
And there you are.
there you are. We now have a sort of thing on the interface, and according to this formula Chris has given me before, I've calculated T1 and T2, and T1 is the charge time, which involves the resistance and the capacitance.
Yeah.
So I basically just substituted them into the equation and calculated that T1 is 3.04 seconds, which means the charge time is 3.04 seconds. And the discharge time, the formula was also given, and I just pretty much put in the values, and I got 1.54 seconds. So overall, the whole period is 4.57 seconds.
Turn on the vertical cursor and then pause and put one vertical cursor there and one there. So that's 4.73.
4.73, so it's pretty close to what we have, 4.57. It could be fluctuating a little bit.
I'll tell you on video, what it likely is the capacitor.
Yeah.
That's 220 microfarads plus or minus 20%.
See, that's why the value doesn't really say like be exactly the same.
No. So
Which is understandable, I guess.
yeah, generally resistors are like plus or minus 1%, and capacitors are like sometimes even plus or minus 50%.
Yep.
It's
Alright.
significant.
So as you can see, this is what TinyLab can do, just to what does it do actually? To calculate the period, to work out the period, to really test out.
Well, to actually look at how your circuit is changing in real time, you can actually does have the period. Like you can do anything with it. That's the point.
You put it like cursor over there, and thank you very much for the second experiment. I now have a better understanding of it.